And we're live. Welcome everyone to SQL Friday. This is number 26, and the star of today is Will Velida, who is presenting from New Zealand, and he's going to talk about machine learning in C# and machine learning.net. So it's more developer oriented than we are used to, and I'm really looking forward to see what you have to present, Will. The stage is yours.
Awesome, cool. Let me just take control. And present. I'll share my screen. Stand by. Let me know if you can see the screen.
It's coming. Yep, I can see the screen.
Awesome, fantastic. Well, good afternoon, everyone, or good evening from New Zealand. Welcome to this session on machine learning in C#, an introduction to ML.net. My name is Will Velida. I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand. I've been living and working in Auckland for around about 10 years now, but I'm originally from the UK. So I still kept on hold on to my accent, but I'm slowly coming around to acclimatizing to New Zealand. It is summertime, which is nice. I don't miss the British winters. Anyway, I'm a C# developer in my day-to-day. I work on a variety of different technologies, ranging from Azure Cosmos DB, Azure Functions, Event Hubs, storage, etc. But I also like to play around with ML.net when I can, hence the talk today. So in today's session, what I'm going to do is I'll go over what ML.net is and just talk about what kind of predictions we can perform using ML.net. Then I'll talk about the different ways that we can use ML.net to build machine learning models using the model builder tool, command-line interface tool, and the API itself for when we want to build more custom solutions. I'll touch a little bit on the performance of ML.net, but throughout the session, it's just going to be, we'll just go through the basic concepts of what ML.net is, what the different tools are, and I'll be going through some demos. So hopefully everything will work out fine. I was testing my demos frantically about 15 minutes before the talk, and it was all working. So let's hope the demos play nice. And at the end, we'll have a Q&A session. So if you do have any questions, just wait till the end, and I'll be happy to answer them then. Okay, cool. So what is ML.net? Essentially what ML.net is, it gives us the ability to add machine learning capability to both our online and offline .NET applications. And with ML.net, essentially we can make predictions using the data available to us within our .NET applications. Now, central to ML.net is the idea of a machine learning model. And essentially this model specifies the steps needed to transform our input data into predictions. And with ML.net, we can train a custom machine learning model by specifying the algorithm we need, or we could leverage other libraries and import pre-trained models. So for example, if we have a model that's trained using TensorFlow or Onyx, we can use ML.net to import those machine learning models into our applications. And then once we've trained our model, we can add the model that we've trained to our application in order to make predictions. Now, in ML.net, we can perform a variety of different predictions due to the different tasks that we can perform using ML.net. A machine learning task is essentially the type of prediction being made based on the problem that we're trying to solve with the data we have. Now, in ML.net, we have a variety of different algorithms available to us based on the type of task that we need to perform, depending on our scenario. What I'll do is during the Q&A session, I've got a bunch of links to just various different documentations all over the place, which you can have a look at to investigate further. But here are some example machine learning tasks that we can perform in ML.NET. So we can build classification applications. So say we've got a customer feedback site and we want to detect whether that feedback is negative or positive. We can perform some classification machine learning tasks to assess that. If we're predicting the price of a product, we could use regression for that. If we're building applications that are detecting fraudulent transactions, we can perform anomaly detection. We can build recommenders. So say if we e-commerce site and we want to suggest a product to our customers based on their previous purchases, we can use ML.NET to build those recommendation applications for us. We can perform time series tasks, so forecasting cost of products over time, or we could do some image classification. Essentially, we might have a fun little mobile application where we take a picture of something and we'll be able to classify that image, whether it's a cat or not, or whether it's a banana or not, depending on what your mobile app to do. So how can we build machine learning models in ML.NET? When it comes to building models, we have a variety of different options available to us. We have two low-code options, and this is both the model builder tool and the command line interface tool. Or we can opt for a code-first option to build more customized models using the ML.NET API. And throughout this talk, what I'm going to do is I'm actually going to go through each tool, what it is, and how we can build models with it. So let's start with the model builder tool. Essentially, with the model builder tool, it's a graphical tool that we can use to build, train, and deploy custom machine learning models. It uses AutoML, which is just a process of automating the process of applying machine learning to real problems, to explore different algorithms that we can apply to our data, and it finds the best one to suit the problem that we're trying to solve. Now, the great thing about the model builder tool is that we don't need to be experts in machine learning to use it. All we need is just our data and the problem that we're trying to solve. The model builder tool will generate the code that we need to add our model to our .NET application. So let's go through our first demo. So what I'm going to do before we get started, I'm actually going to show you the model builder tool extension. Essentially, it's a Visual Studio extension that we can get from the Visual Studio Marketplace. And essentially, we can just download it and apply it to our installation of Visual Studio. But I've done that already. So what I'm going to do, I'm just going to create a simple .NET Core console application and show you how the model builder tool works step by step. So I'm going to create, make sure, yep, console build application. So I'm going to go taxi fare before. You might think that's a weird name for a project, but I'll show you why I've done that a little bit later. Essentially, throughout this presentation, I'm going to use a hypothetical example of predicting how much a taxi fare trip will cost based on a few columns, features and columns. So essentially, I've just got this CSV file here full of randomized taxi fare trip data, and I've got who the vendor was, what the rate code is, how many passengers were on that trip, how long the trip time was in seconds, how far the trip was in terms of distance, how they paid for it, and how much the trip cost. Cool, just going to shut that down, don't want to save it. Okay, let me zoom in a little bit. So what I'm going to do, I'm just going to add a data folder to my project. I'm just going to get that CSV file that we saw earlier, stick it in that data directory, and then just make sure we copy if newer. All right, now let's start to use the model builder tool. So it's very simple to use it once you've installed it. So I'm just going to right click my C# project. I'm going to add this machine learning. So with the extension, once you've installed it, you'll be able to see this, add it to your project. Excuse me. Cool. Just get rid of the output. Now, once we've opened up the model builder tool, we'll need to select a scenario. Now, with this tool, we can perform a variety of different scenarios. So we can do some text classification, we can do some regression, image classification. This is really neat if you have an Azure Machine Learning workspace. You can use that as your training environment rather than your local machine. You can do some recommendation scenarios or even some object detection. But for this example, what we're going to do is we're just going to use value prediction, which is just regression, which will use our local computer. So I'm just going to use my machine. And then we need to add some data. Now, with the model builder tool, we can either provide it a file, or we can actually connect it to a table within SQL Server. There are limitations to this, which I'll discuss at the end of the demo. But for this purpose, I'm just going to get that CSV file. And once it's loaded, we'll be able to preview it. Now, with this tool, what we want to do is we want to predict, we want to tell the tool which column we want to use to predict, or which will be our label. And for this, since we're predicting how much a taxi fare trip will cost, just click on fair amount. Once we've done that, we see a little bit of a preview. So we can see the fair amount as our label, and then the vendor ID, rate code, passenger count, etc. will be known as our features. So just click next step. And then we specify a time to train. So essentially what we're saying is, okay, within the next 10 minutes, I want you to train some models over this data set and then pick a model with the best performing and best fitting algorithm. So I'm going to click start training there. But what I've done before, what I've done earlier, I've just let this run through, see if this provides an output in time. So as it's training, as it's iterating over our data, it's just assessing some models. And it's just determining its fit and showing us some metrics. But I'm not going to make you all sit here and watch me do this for 10 minutes. So here's what I've made earlier. And essentially here, we've got a nice output of all the different models it's trained, along with some metrics. And as we can see here, it's provided us with some training results. So we see a best quality. So this indicates to us the best fit, which model has the best fit over our data. Suggests to us the best model, how long it took to train, and how many models it explored. So once we've done that, we can then evaluate that model. And essentially what the model builder tool will do is just provide us with some sample data that we can use to predict what our fair amount will be based on the features that we've used to train our model. So if I click predict, we'll see a predicted fair amount based on this criteria. So that's kind of a cool way to just quickly do some dirty testing over your model that has been suggested to you. And then once we've evaluated our model, we're happy with it, we can add it to our solution. And essentially we get two projects created here. So we've got a console application, which shows us an example of how we can actually inject a model that we've trained into an application. Got some compile errors there. I think that's just Visual Studio misbehaving. And then we've got a project for our model. So here we've got our serialized version of our machine learning model that we've trained. We have an class. So essentially this is the data that we input to train our model. And then we've got our output class here, which is essentially the fair amount that we want to predict. And then this consume model class just shows us how we can actually create a prediction engine, which I'll talk about a little bit later, which we can then use when consuming it in our applications. Cool, so that was just a really basic way of how a really basic demonstration on how we can actually use the machine learning ML.NET model builder tool to generate a machine learning model for regression. So what I'm going to do, just go back to here I was. Don't start from the beginning. Damn it. Apologies. There we go. Okay, cool. All right, before we move on, there are some current limitations to the model builder tool that we do need to keep in mind. Currently, this extension only works on Visual Studio for Windows. So if you're using Visual Studio for Mac, you won't be able to use this. That's a current limitation. The training dataset limit is 1 GB for files. And if you're using SQL Server, that has a limit of 100,000 rows for training. So those are just some limitations to keep in mind when using this tool. All right, let's move on to the command line interface tool. Now, the command line interface tool is a .NET Core tool. Essentially, you provide it with a machine learning task and a training dataset, and it will generate an ML.NET model, as well as some C# code that we can use to run our model within our applications. Now, with the ML.NET CLI tool, there are some advantages and disadvantages. One of the disadvantages compared to the model builder tool is that we're limited in the tasks that we can use. So at the current time of speaking, we're limited to classification, regression, recommendation, and image classification tasks. But it's an evolving tool, so more tasks are being added. However, on the plus side, the command line interface tool is cross-platform. So unlike the model builder tool, which is limited to Windows, this can work on Windows, Linux, and Mac OS. Now, when we use the command line interface tool, it will generate a serialized zip file containing our model, along with a C# solution that we can use to both train the model again for future use and to run the model so we can make predictions. We'll get a log file that shows us the information of all the multiple algorithms that were assessed and evaluated. And we can use this to investigate other algorithms that we used, or that were assessed, sorry. So if our scenario changes, we can use this as a source of investigation. All right, let's crack into our second demo and go over the command line interface tool. So what I've got here, let me just, screens are being funny today. Okay, so I've got my command line interface tool open, and essentially what I want to do is I want to perform the same regression scenario that I did before, but this time just using the command line interface tool. Now, to install this tool, it's essentially just a .NET tool. So if you have .NET installed, or .NET Core installed, and you have the .NET Core command line interface, if it's on your command line, you should be able to run this. What it is, it's just .NET tool, install. We can install this as a global tool, ML.NET. But luckily, I've already done that. I don't want to make you guys sit here and watch me install stuff. So just type in ML.NET. And as you can see, there's a variety of different options that we can provide it. So as you can see, we're limited to the types of machine learning tasks that we can use with a command line interface tool. So classification, regression, recommendation, and image classification. But what I've got here in this directory, I've got my CSV file. So what I'm going to do is I'm going to kick off that regression tool. So all we need to do is MLnet, and then we need to provide the type of task that we want to perform. So in our case, this is regression. Then we need to provide a data set, and this will be our taxi fare training set. Then we need to provide its label column. And this is the label that we want to predict. Now, I've provided it a value of 6, and the reason why I've done this is that it was zero-based indexing. So we have our file, and we'll have columns within that file, and it will start from 0. So your first column will be 0, second 1, 2, 3, n, etc. And since our fair amount is at position 6, that's the label column that we need to provide it. Then we just need to tell the file, or tell the command if whether the file has a header or not. In our case, it's true. And then we need to provide it a training time. And this time is in seconds. So we could train it for 500 seconds, 600 seconds, or even 10 seconds. And then over that time, it will actually iterate over our data very much like the model builder tool did, and just assess different algorithms and then produce an algorithm that's the best performing for us. However, here's one I've made earlier. So there we can see our ML.NET task up here, trained it for 10 minutes, and it's iterated over our data. And then we get this nice little summary here. So we get the machine learning task that was assessed, the data set, what label we were trying to predict, how long the experiment took, and how many models it explored. And then we can see right down at the bottom here, we've got some code generated. So we've generated our C# code for model consumption at this location. And then we've also got a log file that we can use for more information, and if we want to investigate this a little bit more. So let me have a look for that code so I can just show you what was generated. And essentially it will be pretty much the same thing that the model builder tool generated. So we'll have two applications, one for our model and one for our console application. Just give Visual Studio a second to warm up. Come on, sweet. So here we've got our two projects. Again, there's our serialized machine learning model in zip format, our input class, an output class. Just get rid of output for some more real estate. A class to help us consume our model. And then we've got our example console application that shows us an example of how we can actually consume the model within our application. Cool. So again, really simple, really straightforward way of generating a machine learning model using the command line interface tool. Okay. Cool. All right. Now let's turn our attention to the ML.NET API. So with the command line interface tool and the model builder tool, these are low code options that we can use to generate machine learning models. But here we can now build more customized versions by utilizing the API. And let's break it down right from the start. So each ML.NET application that uses the API starts with an MLContext object. And essentially, this is a singleton object that contains something called catalogs. And these catalogs provide methods for performing a variety of different operations that we need when we are building our machine learning pipelines. So for example, we'll have catalogs that load our data, we'll have catalogs that prepare our data for our pipeline, we'll have catalogs to train the algorithm that we want to use to solve our problem, and we'll also have catalogs to use the model once we've trained it. So using the API, we can actually load our data from either files or other external sources. We can load data from a single file. We could have multiple files within a single directory, or we could even have multiple files in multiple directories. No matter what combination of those that you have, you can load those files into your ML.NET applications. You can also load data from a variety of different relational stores, as long as they're supported by the system.data namespace. This includes SQL Server, Azure SQL Database, Oracle, SQLite, Postgres, and many more. Or we can even load data from in-memory collections or JSON and XML sources using a method called load from enumerable. This method does assume that the IEnumerable object that which you're loading your data from is thread safe, but if you have JSON data, you can load it into your ML.NET applications that way. Now, when we load our data into our applications, we load them into a data view object for transformation. And these data view objects are core to pipelines in ML.NET. Each transformation will have an input schema, so essentially the data names, types, sizes that the transform expects to see as an input, and also an output schema. So again, the data names, the types, and the sizes that the transform produces after the transformation. And essentially, these help kind of link the pipeline together. So if they don't match, so if you have an output that doesn't match an expected input, if these don't match, ML.NET will throw an exception. So, yeah. Then once we have our data, we need to prepare our data in a format that's expected by the algorithms that ML.NET provide. And this may involve cleaning our data, working with different types of data, replacing missing data. Most effort involved in machine learning is actually preparing our data, and ML.NET has a variety of different catalogs available to you in order to make that happen, or to make the data acceptable for use in ML.NET applications. This is able to be done through the data operations catalog, which has a variety of different operations that we can use to take our incoming data and produce an iDataView object containing the data that's ready for use for our applications. Now, depending on the nature of our data and the problem that we might want to try and solve, our approach to data preparation will change. The thing to note is that all algorithms in ML.NET will expect a float vector of a known size as an input. Essentially what this means is we need to convert our data into numerical format and process it into a features column in order to predict a label. So taking this code snippet as an example, what we're doing here is we're creating an output column for the label or value that we're trying to predict, and that's a fair amount. We're then transforming our categorical data by applying one-hot encoding on 3 input columns and producing 3 output columns. Now, for those of you who may not know what that is, one-hot encoding essentially takes a finite set of values and then removes implicit ordering within our data. So if you think back to our CSV file, we had a payment type, and we had a payment type for cash, credit, and check. Essentially what one-hot encoding does, it will convert them into numerical values and then remove the ordering of it. So it doesn't think that more important than 3, or 3 has a bigger weight than 1. It just essentially says these values belong to group 1, these values belong to group 2, and there's no ordering amongst them. Now, once we've transformed our columns, we're then concatenating them into a vector column called features. And after this is done, we append the algorithm that we want to use in order to solve our problem. And then once our data is processed, we use the fit method to train the machine learning model with our regression algorithm that we're applying here to our pipeline. Now, in order to make a decision on how well our model will perform, we need to evaluate its performance on test data. In the wild, you might have a massive data file, you might have a massive table, and you'll want to split that into training data and testing data. And with this testing data, we can actually use this to assess how effective our model is by using the evaluate model method. Now, depending on the type of machine learning task that we're performing, ML.NET will produce different metrics for different tasks. So there'll be different metrics for regression, there'll be different metrics for classification, etc. In this example, what we're doing here is we're loading our test data into a data view object and then using our defined model to make predictions on our test data. Now, the evaluate model here applies to a regression model. So we evaluate our predictions to the label that we're trying to predict, along with its score and extracting the R-squared value. There are more metrics that get generated for regression, but this is just a small example. Now, in ML.NET applications, when we build our model, they're only available in memory. So once we stop our applications, we'll lose our model. But luckily for us, MLContext will have a catalog for actually saving our models. The process of saving and using models are universal to all different types of algorithms in ML.NET. Now, when we save our model, we'll need two things. We'll need the model itself and the data view schema of the model's expected input. So when we retrain our model, we know what the schema is to actually assess its effectiveness against new data. So that will be our input class. When we're loading our model, we can simply call the load method if loading a model that's stored locally, or we can use a stream to load a model that's stored remotely. Now, once we've built our model, we can input data to make bulk predictions or a single prediction at a time. And for this purpose, we create something called a prediction engine, which is just essentially a class that helps us make predictions. So in this example, what I'm doing here is I'm calling the predict method and passing both the model that I want to use and some input to make the prediction. Just something to note, and I'll show you this in the demo. With prediction engine, bear in mind that this isn't thread safe. So if we're making a single prediction, it's okay. But say if we want to make multiple predictions, or we have different instances trying to make multiple predictions, you would have to create multiple instances of prediction engine everywhere, and as your application grows, this will become unmanageable. So in this example here, and what I'll show you in the demo in a little while, is that we use something called a prediction engine pool. And essentially, combining this with dependency injection, we can use a prediction engine pool, which will create an object pool of prediction engine objects that we can use throughout our application. So this is just a basic workflow of how we can use the ML.NET API. So we could start with training and collecting our data, and then creating an iDataView object for our trained data. We'll then create our pipeline, train our model using the fit method on on the pipeline with operations to extract features and applying the machine learning algorithm that we want to use. And then we can use the evaluate method to evaluate the model and iterate to improve if we need to. If we're happy with it, we can save the model into a binary format for use in our application. And then we can load the model back into our application using a iTransformer object and make predictions by calling our create prediction engine and using the predict method in order to do that. All right, so let's jump into our API demo. Now what I've got a bit more of a sophisticated application, a bit more of a sophisticated demo. And I've got two projects here. So I've got a model trainer and a API. So in this model trainer, what I'm going to do, I'm actually just going to see if I can just close all of these so I don't lose my place. So this model trainer is essentially an Azure function that works on a timer trigger. And what it will do, I'll just increase the size a little bit. So every 5 seconds, we're going to authenticate to Azure Storage, read I've got some local testing and training data here. And I'm going to train and save my model to Azure Storage. So I'm going to create a machine learning model based on some local data. And then once I've created my machine learning model, I'm going to put that into a blob storage account. And I'll show you why I'm doing that in a bit. So let me check startup. So nothing here really to see. So this taxi trip model. So essentially, if I look at the dependencies, if I see these two packages, we've got Microsoft.ml and then Microsoft.ml.fasttree. So if I go into my NuGet packages, when we want to use ML.NET or use the ML.NET API, we can essentially browse these packages. So we've got a variety of different packages depending on what we want to do. So we've got the generic Microsoft.ml, which provides us access to the MLContext and all the catalogs available to us in order to perform and build our machine learning pipelines. And then for different types of algorithms, we've got different packages for that. So FastTree is the one that we're using. We've also got one for like GBM, etc., etc. So one potential workflow that you could adopt is that you can use the model builder tool or the command line interface tool to just iterate over your data at a very high level if you're not really sure what algorithm you want to use, and then you actually drill down into the API and build a more customized solution based on a recommendation that either one of those tools makes. But I've already gone ahead and installed these two packages, so we don't need to worry about that. And then I've got my input class here. So essentially, remember our file, and we're essentially telling this input class when we load that file and then serialize that to this C# object, we've got all these annotations for telling this class which column for which to load the data to and assign it to which property. So we've got vendor ID, rate code as column 0, 1, 2, 3, etc. Cool. And then I've got a model here, a class here that will actually show, will actually tell our application what we're trying to predict. And this will be our column, we have a column name of score. All right, so let's go into the function itself. I'm going to just kick this off. And what I'll do is we'll step through it as we go along once the function starts. So see a lot of red. Oh, no, that's good. Sweet. Hopefully that won't take too long. Cool. Okay, so I'm just going to do some basic authentication to my storage account. Just picking up my local training data and testing data. And then we're going to step into this train and save model. So here I'm passing in this MLContext. I've got a train data path, my testing data path, a defined model path that I want to save it to. And I've also got the container that I'm going to save my model to. So step in here. Cool. So first off, we're going to load our file into the pipeline. So here we're using the data catalog to load from a text file. And we're casting it to a taxi trip. We've got this training file path and telling it, hey, here's the file. It has a header, and this is my separator character. If we were loading it from a SQL Server table, we provide it a different method, but this is how we would load it from just a normal text file. And remember, this text file is just a single file within a directory, so it's just nothing too elaborate, just something really basic. So now we're training our pipeline. So with this pipeline, we're transforming our data. So we've got a input column name for fair amount, and this is our label that we want to predict. So we're really just copying this column and then creating an output column called label. Then we're transforming our categorical data using the one-hot encoding. So the vendor ID, rate code, and payment type is all categorical data. We're just applying that one-hot encoding just to provide a numerical input for our algorithm without applying any ordering. And then we're concatenating our columns for vendor ID encoded, rate encoded, passenger count, trip distance, and payment type encoded into this column of features. And then we're applying this fast tree algorithm in order to apply a fast tree regression algorithm onto our pipeline. Once we've done that, we'll fit our model, or fit our pipeline onto our model, onto our data, sorry. It won't take too long, and then we can evaluate our model. So let's step into this evaluate method. And essentially here we're now using our testing data. We're saying we're using the same method, so we're loading it from a text file. Once we do that, we then apply it to our model. And then we get some metrics. Now, before I go any further, with these metrics, we've got different types of metrics here for regression. So we've got loss function, mean absolute error, mean squared error, R squared, and root mean squared error. And depending on the type of algorithm that you're using, you'll get different metrics. So this is just specific to regression. But here, all I'm interested for the purposes of this demo is just getting this R squared value, which just determines the fit of the model. And then I'm returning that. And then with these metrics, you can actually use this to use this information to just tell your applications, okay, I want to retrain it again using a different part of the data set, or if it's good enough, then we can actually save that model and upload it, which is what we're going to do here. My R squared value is over 0.7, just for a demo. And then we're going to save our model, provide the schema to this model path. Once we've done that, we're going to actually upload it to blob storage. It's done. We can then go into our Azure storage account. And all I've got here is a very simple container within, oh, I want to see you, within an Azure storage account called ML models. And there we go. There's my serialized model ready to be injected into my applications. So that was the first part. That was our model trainer. And now for our second part of the project, we've got an API here where we're actually going to be consuming our model that we've got in Azure Storage, and then use that to make predictions based on some incoming requests. So I'll open up my startup file. And here, what we're doing is we're just injecting this add prediction engine pool into our Azure function, which is an HTTP trigger. So here, when we add our prediction engine pool, we've got an input class of taxi trip, which is similar to the class that we had before, and then an output class of taxi trip fare prediction. And here we've got a couple of ways that we can actually inject a remote model. So in this example, I've got from URI. I've given it a model name. Now you can name this model whatever you like when you call it from a URI, but throughout your application, you have to use this name once you've named it. So you can use whatever name you like, but you have to be consistent when you're calling this model throughout your application. I'm telling this method where it's living in this URI. So there's the remote location where my model is. And then we've got period, which essentially is saying, okay, every minute I want you to poll this location and check for updates. So say if you're doing real-time training on your model and you're constantly updating your model, this will then poll that remote location every minute just to check for an update. Another way you can do this, say if it's not on a URI and you've got it on a remote, if you've got it in a local directory, sorry, you can actually point it, the prediction engine tool, to your model where it's living in your local directory, and then it just polls that local directory for any updates to your model. Cool. So now that we've injected our model, we can now use it within our application. So this is just this very basic HTTP trigger, which is going to make a post request. We're going to deserialize our input request to this taxi trip class. Then I'm going to create a prediction based on our model name from earlier and the input that we provided. And then I'm just going to return the result back to the client. So let me just start this API. And for this, I'm just going to use Postman to make my post request. Once this kicks up, sweet. So there's my URL for my function. It's all ready to go. So here's one I've made earlier. Here's a request I've made earlier. So I'm just going to send that and we'll step through the application. Sweet. Open you up. So I'm going to read the incoming request, deserialize that into my taxi trip object, and then make a prediction. Sweet. So then I've got my inserted prediction. So I've got this insert object, which kind of encapsulates both the input and also the prediction. And for this predicted fare amount, we can see how much this particular taxi trip is predicted to cost. So once we've done that, we can just return that back to the user. And then in Postman, keep going. Just open that up a little bit. There it is. So say if we had a web application or a mobile application, we could then return this response back to the user. So again, a very basic example, but just kind of a cool way that we can actually build machine learning models using ML.NET, using the API, and then injecting that model back into a different application. Cool, let me go back to the presentation. Sweet, so what we've covered today, we've discussed what ML.NET is, what type of predictions we can do. We've also discussed the various different tools, the model builder tool, the CLI, which are really, really cool low-code ways of doing some investigation around machine learning, so we can understand, we might have a task in mind, we might have a problem in mind, and we want to do a little bit of investigation. and then we can use the model builder tool and CLI tool to help us out which algorithm we should be using. And then we dived a little bit deeper into the API to build more customized solutions. All the demos worked, which was great, or they worked how I intended, which was great. Now, if you want to learn more, I'm going to pop these links in the slide and in the YouTube video. I'll comment below. But if you want to learn more about ML.NET, I definitely recommend checking out the GitHub samples. There's some fantastic examples ranging from regression, image classification. There's even some in F#, if any of you are coding in F#. There's samples in C# that you can use to just clone, have a play around and get your hands dirty. ML.NET documentation is really, really good, really straightforward, really simple to get your head around ML.NET. So if you want to learn more, definitely check that out. I've got a link to the serverless price predictor, so the application that I just demoed. That's on my GitHub. If you want to have a play around with that, check that out. Please do. It's yours to enjoy or not enjoy, depending on how you find it. And I've also got links to the ML.NET Model Builder tool if you want to install it, as well as a guide to installing the ML.NET command line interface. Well, thanks for coming. Thanks for listening to me. This was really, really fun. If you want to reach out to me on Twitter, I'm at Velida, or if you want to connect with me on LinkedIn, ask me any questions at any time. I am in New Zealand, so do expect a bit of a delay due to time zones. But if you do have any questions, please feel free to reach out to me. And thanks for coming.
Thank you for coming. It was a great demo, or a great presentation with lots of demos. Really. From nothing to something. So thank you. Do we have any questions from the audience or comments? Watching the chat, and I see Stefan and Marcus are typing, so we'll see. We're not that many, so if you want to, you can also just unmute yourself. Stefan just says great presentation, and I agree. I was just looking at the numbers in the last demo, comparing the Fairmount to the predicted Fairmount, and I guess choosing a good model is important.
Yeah, definitely.
Great and deep dive. We'll try it out. Yeah, and that's the same for me too. I'm not a C# developer, but I can at least read code and I can do some changes to code. So I'm gonna do some playing this weekend to see what I can do.
The great thing that I found with ML.NET, because I've played a little bit with Spark and writing Spark applications in PySpark and Scala, it's very similar. Even though they're two different languages, the workflow is very, very similar. So if you're coming from writing Spark applications in Scala, it won't take too long to get your head around building machine learning pipelines in ML.NET.
Cool. Yeah, I mean, I'm a SQL guy, so Python and PySpark, it looks strange, but I mean, it's the same thing. It's basically English with some dots and parentheses in different places. So it's usually easy to read, at least. And I see we have a result from the presentation. Marcus says that he is into ML a lot. So this is definitely something I will look more at. And I guess that's why we do these presentations, to people to further explore things. Alexandra says, in SQL Server Big Data Cluster, it can be a scenario, PySpark, Scala, etc. Yes. There is a lot around machine learning happening. So it's for me, I think the biggest obstacle is getting the time to keep up with the pace of the development in this area.
Yeah, totally. The last time I touched Spark.net, so the C# library for building Spark applications, was when it was still in preview, and I hadn't touched it in a long time. And all of a sudden, 1.0 came out. I think either on Ignite or just after Ignite. It was around that time where they released 1.0. And that's something I definitely want to explore a lot more, building Spark applications in C#.
Yeah. And I think this is one of the cool things that is happening, that if you have your favorite language or your favorite tool to work with, you get support for things that used to be in one language or one tool, and you can basically build your own in any language or any tool nowadays, because everything is so open. And I think that's a big difference. Microsoft has played a big part of this, and they have changed their way of trying to lock people into their products, and instead just opening up so you can use whatever else you want together with their products. Also available ML services and big data cluster. ML.net will be useful there, I think, Alexandra says. Yeah, I again want to thank you so much. The presentation was a great inspiration to go deeper into this area. Regarding the slide deck, could you send that to me, or do you have a GitHub link where you have the demo code and the presentation?
Yeah, I can send that to you. Let me see if I can grab it very quickly off my GitHub account. 3, 2, 1 in the chat. Perfect. There we go.
Then I'll just put that on SQLfriday.net, where I embed the YouTube video. I'll just put the link up there as well, so that anyone can download the code and follow along.
Awesome.
Great. I think I am going to have to say goodbye and go into some meetings starting in 2 minutes. But thank you again for coming to SQL Friday. Thanks everyone else for joining us today.
Awesome. Thanks for having me.
Hope to see you in person. Like I say to everyone, although I like the opportunities with virtual events, I want to attend in-person events and actually shake hands, drink beer, what have you. Soon, yeah.
Hopefully.
Soonish, I guess.
Yes.
We'll see. But again, thank you. Just check out SQLfriday.net/schedule for the upcoming events. I am doing session selection for 2021, so the schedule for next year will be published in a week or two. So have a nice weekend, and thank you again. And good night to you, Will, I guess.
Cheers. Thanks,
Bye.
everyone. Bye.